Thank you for attending my presentation. My name is Elène, and I am presenting my PhD work on individual differences in sampling behavior in eastern chipmunks. Many foraging organisms are faced with uncertainty because the state of resources changes, and unless they are associated with cues, their current state cannot be known by foragers when they are not present at the resource. There are many strategies to deal with uncertainty, and one is sampling, which simply means resource tracking. Sampling occurs when a forager returns to a previously unprofitable resource to update information about its current state. This behavior is advantageous because individuals do not need to search for new resources and can resume using the resource when it becomes rewarding, but is also costly as a result of time and energy constraints and because of the potential to miss opportunities elsewhere. In my study, I looked at sampling in individually marked eastern chipmunks to assess whether individuals differ in their sampling behavior. I was also interested in determining whether sampling could be predicted by exploration in an open field, as this behavior is thought to reflect information gathering, and whether sampling is beneficial by increasing the speed with which individuals rediscover resources when they become profitable. My study population consisted of 32 individually marked chipmunks with passive integrated transponder tags and 16 feeders located throughout the study site that recorded the marked chipmunks when they entered and exited the feeders. Over the course of the study, I filled feeders with sunflower seeds that chipmunks consumed and unpredictably emptied the feeders. Based on whether individuals used the feeder when it was full, I summed the sampling visits they made when the feeder was emptied. I then used this value to determine whether individuals that sampled more were faster to rediscover the resource when feeders were refilled. This was repeated 6 times during the study period for a total of 129 observations. I then assessed whether sampling visits were related to the distance between feeders and burrows, as I expected travel costs to reduce the benefits of sampling. And I assessed whether sampling differed between males and females, because males are typically more active than females and may rely less on sampling known resources. Finally, I expected exploration profile in an open field to relate to sampling, with more thorough explorers in an open field conducting more sampling visits. As predicted, sampling decreased with increasing distance from the burrow, but there was no effect of sex on sampling. Individual identity explained about 18% of the variation in sampling behavior, indicating that it is repeatable. Interestingly, there was no relationship between sampling and exploration in an open field among individuals. Overall, sampling visits did increase the speed at which individuals rediscovered the resource, but there were no differences among individuals in this relationship. Overall, I found that chipmunks sample more when feeders are closer to their burrows, consistent with the hypothesis that travel costs should decrease the benefits of sampling. I did not find an effect of individual state on sampling, such as sex or exploration in my study, suggesting that the optimal sampling strategy is similar for all individuals in this population. Finally, I did not find among individual differences in the relationship between sampling and resource rediscovery. However, I am next interested in determining whether individuals differ in their sampling plasticity, meaning that with increasing time since the feeder was emptied, to quantify whether some individuals give up sampling sooner than other individuals. Thank you very much for attending, and I look forward to answering your questions.